Good morning and welcome to today's Water and Waste Digest webinar titled Take Your Water Distribution System to the Next Level, sponsored by Innovyze and Autodesk Company. I'm David Pazaricki, Senior Director of Webinars with Endeavor Business Media. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during today's session, please put your question in the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your question during today's event. We will answer as many questions as possible during the Q&A session that'll follow the main presentation, but please feel free to send your questions in at any time. To do so, simply type your questions in the question window at the side of your screen and hit the Submit button. Also, please be aware that today's session is being recorded and will be available on the Water and Waste Digest website within the next 24 hours. You will be notified by email when the archive is available. Now, I'd like to introduce our speakers. Tim Medeiros is a systems engineer at Innovyze. As a solutions engineer with the American States team at Innovyze, he is a certified professional engineer in the state of Colorado and has worked at Innovyze for over 5 years. Tim's specialty at Innovyze is asset management software product line, Info Asset. He has worked with hundreds of utilities and consultants around the world educating, implementing, learning about, and discussing the best asset management practices for wet infrastructure networks. In his free time, Tim enjoys the Colorado outdoors, running, reading, spending time with his wife and young children. Joining Tim today is Hunter Sparks, systems engineer at Autodesk. Hunter has over 9 years of experience in the civil engineering industry. He has experience leading projects in geotechnical, land development, utility design, stormwater design, and software sales. Hunter has a BS in civil engineering and a minor in green engineering from Virginia Tech. He is a registered professional engineer in the states of North Carolina and Colorado. Welcome to you both. Tim, the floor is yours.
Perfect. Thank you so much, David. And thank you, everybody, for being here and joining us today. For today's agenda, again, we'll be focusing on kind of water distribution modeling and how to bring in live data analytics, how to bring in some of that telemetry SCADA data into your live models and what you can do with that. So this is the general agenda for us here today, but at any point, do feel free to pop your questions into the chat. We do have a not too big of a group, not too small of a group. We're in the double digits. So if at any point you have a question, please do pop it in. If it fits in the flow, I'll try to answer it right then and there. So you all don't have to wait till the end for your questions. We already had a question about, will the slides from today's presentation be provided? And the answer is yes, those will be provided at the end there as a PDF. So again, the agenda will be looking at kind of the current state of utilities, specifically within water distribution modeling, but utilities, I guess the lens will be a little bit US-based, North America-based for that. We'll look at what's possible with some of the investments utilities have been making and then how we can add, again, a layer of smart data analytics to those to take what you have and advance it a little bit there. We'll look at the math behind these solutions to get us from the current state to what's possible. So everything you're going to see here today, yes, we're Innovyze, we're an Autodesk company, we have our solution for doing this, but everything we'll be showing you today in terms of solutions and how to take what you have and make it a little bit more advanced, a little bit more real time in terms of your hydraulic model. You could, that the math is all engineering, math is all there. You could do this yourselves with your own solutions, but of course, we'll be talking about Insight and our solution for doing this in a nice water-specific dashboard at the end here, and Hunter will be going through that live demo and kind of going through again all the solutions I'll demonstrate in the PowerPoint. It'll be showing that in the actual product here today. So again, thank you all for joining, and we'll get into it here. All right, so again, a little bit on the state of today. There are a lot of challenges utilities are tasked to meet today. So aging infrastructure, workforce retirement, population growth, inadequate budgets. Not only are utilities expected to as they have been in the past, kind of add new infrastructure and maintain new infrastructure for new developments. But we've got this whole wave of aging infrastructure that now it's not just little chunks of the network. When your utility or your town or your city was small, that's aging and breaking. It's larger sections of your network from 1930s, 1940s, 1950s, that's aging, that you're having to come up with dollars for at the same time as maybe accommodating for new network and new CIP funding for additional population growth. At the same time this is happening, talking with utilities here in Colorado, it's very difficult for some utilities to then fill and staff different positions within their utility, while at the same time they have an aging workforce that's taking institutional knowledge out of that utility. Um, so there are all these challenges, along with inadequate budgets, and again, regulatory pressures, fines, consent decrees that utilities are dealing with, all these different ways that the current ways of addressing these challenges is being stretched, right? So how can we take the information we have as a utility, you have as a utility, and again, stretch it further? So that's where, again, some of the solutions we'll be getting into come in here. So we know there are a lot of utilities that have invested a lot in terms of uh, data, SCADA information, GIS information. A lot of networks been talking with lately. Or there's a lot of presentations at each conference about AMI data, uh, hydraulic modeling. This is where Innovyze and Autodesk have led for 30 plus years now. There's a lot of data that utilities have gathered and have created different departments for, and sometimes it's siloed. And so the idea with what we'll be talking about today is how can we better harness this data into a single platform where some of this data is coming together, so that it's not just single teams dealing with single applications and single challenges that individually they're trying to address, but instead how can we use some of these data inputs, um, single data inputs, to do address more challenges. I've talked with utilities here, um, again in Colorado, that have mentioned, an example here is, they've made investments in SCADA information and placing all these different sensors, flow meters, pressure gauges around their whole network. And then they'll mention how, after they make these thousands of dollars of investment, that they no longer know if that sensor's working anymore, it's offline, and maybe nobody cares for whatever reason or another. So we don't want that investment to be ignored. We want that data to be used because, again, there are all these challenges that utilities today are facing, and that data can be very useful in addressing some of those challenges. So, what do I mean by that? What's a good example of this? And again, we'll walk through some of the solutions behind this as well. So, say you're a utility and you add, a flow meter to your network, right? And you're using that flow meter to track whether a pump is on or off, right? And that's being used to track maybe a tank level, and when that operator should be turning that pump on, whether that tank level is high enough, and evaluating that drawdown rate, maybe for that particular tank, right? What we're saying here with Innovyze and some of our new solutions here, namely Info 360 Insight that we'll get into, is that flow meter that's maybe being used for one application and one task, and um, maybe isn't being used as effectively as it could be used for multiple problems that utilities are, again, facing today. So one is, utilities are dealing with main breaks now more than ever because of that aging infrastructure. So how can you use that flow meter for alerting, and getting to those main breaks faster to minimize the amount of damage caused by those main breaks? If that flow meter is obviously spiking, that might be an indication of a main break. How can that flow meter be used for not, emergency activities, but also used to track just general non-revenue water leakage throughout your network or pressure zone? So we'll be looking at that. Tank water age. This is one that might not be immediately obvious, but if you have a flow meter near that tank, maybe you can check, you use it to check, whether that water age within that tank is really increasing and stagnating, and maybe you end up having a water quality issue within that tank, and you can verify that based on some of the flow data coming into and out of that tank, right? And then lastly, the one we'll get into is pump performance. So if you've got that flow meter, and it's it's an indication of how that nearby pump is operating. How can it be used to determine whether that pump is actually operating efficiently and it's still on its curve, or if it's in need of some operation and maintenance there. So yeah, again, bringing this to a dollars level, right? Maybe that flow meter, and again, this is all very ballpark estimates, but just to put some numbers to it to give an idea, maybe that flow meter costs $3,000, and looking at whether that uh, pump or is on or off and monitoring that nearby tank, it's a small issue. Maybe that's a $3,000 kind of issue there. But if you look at what that flow meter could be used for, all these different applications, right? That those main breaks, I was looking at an average from a utility in Ohio, is $300,000 per main break. Now those could be, much more, right? There was a main break recently in Denver, flooded entire neighborhoods. If you can use that flow meter to get out to that main break a little bit sooner, how much could be saved there? Then you've got, leakage monitoring. AWWA study here in the States showed that we're losing $77 million in treated water. That's the amount of money that we're putting into treating water that's then being lost on an annual basis. So if you put that to 1 million gallons, that's $600 per million gallons, which doesn't seem like a whole lot, but as that kind of adds up, that $600 is just really the cost of treating that water. It's not even including kind of the social cost of losing that millions of gallons of water, especially when you live in an arid region like I do here in kind of the Southwest United States. Tank water age is, again, very general estimate, kind of the cost of adding impellers or adding new operations to that pump to reduce the amount of stagnation of water within a particular tank. Again, that cost could range, and maybe that cost doesn't even factor in the consequences, the health and safety consequences of having a water age issue that isn't as quickly detected as it could be if you're actively using that flow meter to check on water age within your tank on a daily basis, right? If you're just relying on field surveys and checking that water age within that tank, that might be missing the problem for 6 months, a year or so. And then lastly, pump performance. If you're missing that pump is slowly wearing down and it's falling off its curve, first of all, the energy costs that go into a utility, almost all those energy costs go into the pump stations. That's um, unneeded, energy expenditure that a utility is wasting if that pump is operating off its curve, and we could have determined that more easily by evaluating that nearby flow meter. And then if you don't realize that a pump is wearing down and you need to eventually replace that whole pump or pump station, that could be a huge cost there. So again, just the idea is this SCADA information, this time series data, we know it's there at utilities. We know that utilities are actively trying to add more of this hardware throughout their networks to evaluate their network in real time, but we don't know, and a lot of times we run into this issue where it's not being used as effectively as it could be. And so when folks see that it can be used for multiple different uses instead of just maybe the initial use case that hardware was purchased for, it becomes much more valuable and can really stretch those thin budgets the utility has a little bit further and address some of these larger problems here. All right, so with that, the next step is getting to these smart solutions and kind of the math behind them. So I'll go through those same kind of 4 solutions, looking at a simple mass balance, uh, an infrastructure leakage index, which is an AWWA certified kind of calculation there for minimizing non-revenue water. We'll be looking at that tank turnover and how you can, again, very simply uh, add that to your day-to-day analysis, and then pump efficiency as well. And again, none of this is machine learning, AI. This is all mathematical, physical relationships that you can start to use based on that time series data you might already be collecting as a utility and actively evaluating your hydraulic networks. All right. So the first one here, how can some of that live data you're getting, particularly kind of flow meter data, be used to create um, a simple mass balance for your network, and what can that be used for? So within a standard hydraulic network, right, you've got water treatment facilities, pumps. You see those on the left there. You've got tanks, lines, and a lot of those will have some of this live time series data uh, near some of those assets there. So you can see the pump stations. A lot of times there'll be flow rate monitoring there, which we've already talked about. Pressure sensors, status of whether that pump is on or off. By your storage tanks facilities, you might have a level sensor. How high is that tank level within that storage tank? And even if you're missing some live time series data, you can still, like in this example, this pressure reducing valve between these two pressure zones doesn't have a flow meter there so that you can track how much water is going from pressure zone A to pressure zone B. You can still, and apologies for the text being a little messed up on this slide. Hopefully that's still pretty legible there. You can still say, okay, I have this entire area here. I know the inflows coming from the left-hand side there. I know the outflows on the right-hand pump station. I know the storage. From this, I know what I'm billing in terms of usage. Maybe that's a lot easier if you have AMI data, but even on a monthly rate, you know what you're maybe billing, what's being consumed by your customers there. You can then start to calculate, okay, what is maybe that non-revenue water there? So this is where we get into, using some of this live time series data. Once you have that kind of balance created there, to identify leak detection here. This actual graph is an example of a customer or a use case kind of example we did with an Australian utility, where we kind of analyzed a past break and said, look, you finally got to this break after we realized that the pipe broke in the morning, and a neighbor had to call, and water was running down the street when they woke up at 7 a.m. But if you were tracking this with live data, and you had your kind of mass balance, and you had those flow meters and tank levels tied together, you had that area isolated so you could see these kind of peak events as you see in that bottom graph. You might have been able to get to and respond to that main break a little bit sooner, and then saved on that non-revenue water, and really minimized that main break event there. So again, if we kind of just take that mass balance a step further and we say, okay, we know inflows, we can isolate a particular part of our network so that we can identify here's what's going in, here's what's coming out in terms of the um, what's flowing out to the next pressure zone. We know the storage within a particular tank, how that's changing, right? With a tank level, maybe there's not storage in that zone. You don't even need to worry about that variable then. We know what we're billing. We can immediately identify what is our non-revenue water, and then work to decrease that and get to these parts where there's a spike a little bit sooner there. All right. So that's, again, the first math behind the solution there. The next one we'll talk about is infrastructure leakage index. So this is, again, an AWWA calculation. You see that in the graphic there on the bottom left. This is generally calculated by utilities on an annual basis. So utilities will a lot of times evaluate, what is my current annual real losses? That's that CARL variable you see there. And what's my unavoidable annual real losses, and the relationship between those two, what I'm currently, what's my current leakage rate versus what's unavoidable based on just the mileage of my network. Um, that's your infrastructure leakage index. So the closer you can get your ILI down to 1, where your current losses are equal to the ones that are unavoidable, no matter how watertight we make our network, that is the main relationship there, right? So a lot of utilities are doing this on an annual basis, but what our solutions, try to really open up is, what if you could do this on a daily basis, right? What if you could track that leakage faster using that time series data that you've already invested in throughout your network here. So again, here's the math behind these equations, been cited in multiple kind of academic papers, and again, sponsored by AWWA's own calculator. And again, sorry for anyone out there, AWWA stands for American Water Works Association. But you see the different variables in there for the unavoidable annual real losses, we're looking at kind of the length of main, length of pipe, and your pressure throughout your network. The higher that pressure is going to be, the more unavoidable losses you'll kind of encounter there. And then your current annual real losses really comes from that mass balance we were just discussing in the last solution. So you can find out what's your quantitative um, non-revenue water there, and then looking at the number of days your network is pressurized, hopefully all 30 or 31 days within the month there, if you're a water utility, distribution utility. But what our solution really does is it makes this a lot easier. You just plug in these values you've already brought into a single platform, so you can come up with this infrastructure leakage index indice much easier, so that it becomes easier to compare, a small pressure zone that's leaking at a much higher rate, but maybe has less non-revenue, total water that's leaking, but at a much higher rate, to a larger pressure zone. You can still compare apples to apples using this ILI indice. All right. Third one here to mention, tank turnover assessment. So here's where we get into that water quality discussion, which is something maybe folks don't always associate with the actual, physical hydraulics of live time series data. But basically, the idea with this tank turnover assessment is, again, we know for that as water stagnates within our distribution networks, disinfection byproducts increase, and our chlorine residual decreases, which leads to poor water quality for our customers. So the idea here is take that average volume of your tanks and compare that to the total volume that's going into the tank each day. So how much volume for that tank is being replaced and actually flushed out on a given day here. So really just one variable you need, and then the average of your tank volume overall. So you can see this example here, and this is exactly how it looks in Info 360 Insight, and that you can set up these analyses that look at your average operating level minus your tank level minimum. That gives you your average depth in your tank. You multiply that by the surface area of the bottom of your tank there. So you've got my tank radius is in there, pi, another variable in there. So I'm just calculating the average volume of that tank and comparing it to the flow rate coming into that tank, the integral of that over a particular day there. So you can see, I think the general rule, what we've seen is if you're replacing about 5% or more of your tank volume on a daily basis, that means you have a total residence time of, I believe, should be about 20 days. That should be in kind of a zone of safety where you'll know that your tank is being flushed enough. You don't need to add a mixer or anything to that particular tank. But if you're out of that range, you might have a water age issue there if the total residence time, parts of that water staying in that tank for months or longer, right? You might have some water quality issues there. And so this is a way to get alerts from that much faster than doing field surveys kind of on an ad hoc basis. This is a way to get that information much faster there. All right, and the last one, and again, we'll go through all of this in the actual software, and Hunter will show you the actual platform and how you can view these results in real time, is pump performance, right? We know the equations for deriving, how much power is being provided by that pump and is actually being, carried through to the actual hydraulics of our network here. So pump power is a function of the flow and the actual head, the pressure difference within that pump station, right? So we want to compare that, the actual pump power that's delivered to what's being supplied to that pump here, right? So to do that, again, we need the pressure, the upstream pressure and the downstream pressure from those pumps. So that way we can calculate that H, that head difference there. We'll need the flow rate on the downstream side of those pumps. So that's the other part of that power equation. And then it's probably obvious based on the flow rates, but if you have multiple pumps within a pump station, it's good to know which ones are on or off so you can identify, maybe this one's working efficiently and this other one, when we have this configuration, we can identify another pump isn't working as efficiently there. So, and if you have these inputs, and hopefully there's also another way without even needing SCADA data to identify, what is the power that those pumps are consuming, right? You can start to look at, again, the pump performance. How efficiently is that pump operating? So again, a very visual analytic that you can create within Info360 Insight, where we've got downstream pressure, upstream pressure. That gives us the head difference. Convert that to, I think this is looking at everything. This is looking at everything in kilowatt hours. So you've got some conversion factors in there. We're also looking at the flow rate downstream. So we can get that power output in real time, compare that to what we know you as the utility might being charged per kilowatt hour to come up with, hey, this pump normally is operating on that pump curve. If you look at that graph from Info360 Insight on the left-hand side, it's normally operating, on that curve if you see the two clusters near the top. But in this case recently, it's operating a little further off of that pump curve. It's maybe operating 85% less efficiently than it should be. Well, that 15% there, that's your delta, that's your wasted energy expense, that's your reason for trimming the impeller on that pump, or doing some standard maintenance on that pump to get it back up and running efficiently, and again stretch those utility dollars a little bit further than they normally would be. All right, so again, the idea with Info360 Insight in our platform is to take this data that we know utilities a lot of times have, and they might just not be gathering it together into a single platform, to be able to use it together with their hydraulic model in a way to solve these additional problems. But the data's there, you have it, and we're here to help as part of Innovyze and Autodesk here. So with that, I think we'll go straight to you, Hunter, and can kind of show everybody the Info360 Insight platform and go through all those same analytics there.
Perfect. Thank you, Tim. I'm going to go ahead and share my screen, which is often the most stressful part of any presentation. So Tim, could you just let me know if you are currently seeing Info360 Insight?
Yep, I think so.
Perfect. Well, thank you, everybody. And as Tim mentioned, we're going to concentrate on Info360 Insight, that cloud platform that Innovyze has developed, allowing you to take your live SCADA data and matching with your hydraulic model, and bring it to the web, allowing you to pull insights out of it. When you open up the platform, you're initially going to be taken to a front dashboard. And in this case, we have created a custom dashboard from our workspaces, allowing you to view the information that would be important to you. So I'm going to run through this dashboard, this workspace, which you'll notice has some of the analytics that Tim talked about. And then we're going to kind of take a look under the hood, see how you would develop these, how you would create these in the software, and then we'll bounce around to some of the other features. So as you can see, Info360 Insight allows you to have custom mappings, a place for you to view, compare sensors, looking at those diurnal patterns that can be created with your live sensor data. The pump performance chart that Tim was talking about, by bringing in the pump performance curve as well as using that live sensor data, you can start really seeing if the pump is operating optimally, or if you need to go out and do any sort of improvements to make sure that that efficiency is not wasting any energy. Info360 Insight also gives you a platform and a way to just view that live sensor data as it's coming in, whether it is a tank that you want to look at the operating range, if you want to look at different pump flow rates and compare them. You can also set up pressure gauges that have operating ranges that you would expect them to be in, as well as setting up notes mentioning really whatever you would want it to say. In this case, letting the note to the operator, letting them know that they might need to investigate further. And this can bring in all kinds of sensor data, whether it's pressure, flow rate, tank levels, really just giving you a place to view all of that information in an easy to digest dashboard. As well, in these dashboards, this is where you're going to start recognizing some of the things that Tim went over, whether you're looking at the mass balance, you're looking at that infrastructure leakage index to try and break down where you might need to try and improve leakage, looking at that non-revenue water to see if you have a burst event, or just trying to monitor your system for non-revenue water. As Tim mentioned, people submit water audits. They look at this once a year, and unfortunately, by just looking at it once a year, you could miss a window to really fix a problem and really get ahead of that non-revenue water. The pump performance dashboard, the custom analytic that Tim discussed, as you can see here, and then as well as that tank turnover. So this is just an example of how the dashboards really gives you a place to store your information, set this up in different avenues. But what's going on under the hood? How are you developing these? How are you creating these? That's the next thing that we really wanted to go into. So as you can see on the left-hand side, we have some different panels that you can go to, and we're going to go ahead and jump into the tools. And as you can see with the tools, currently we have 4 that are built into the software, and we're just going to march from left to right and talk a little bit about each one. So starting with that mass balance, looking at that non-revenue water as well as the inflow-outflow usage, that's where that billing data can really come in handy. And what's really nice about the mass balance is we provide the tools for you to break down your system. We are there to help you if you would like us to help you delineate these DMAs, these zones. However, we also know that you are the expert of your own zones. So really, with a simple user interface, you can choose which sensors are assigned to which zone. And this is where, as Tim mentioned, you're breaking down your system into those DMAs. But really what you're doing is you're selecting the sensors that would establish this mass balance by tagging a live sensor for the inflow, the outflow, the storage, and the billing, as well as being able to look at this continuously so that it continues to go from a certain date all the way to the present, or if you want to break it down and create different mass balances for different months, if you know that during the summer months you tend to have more non-revenue water that you want to look at, you can break it down that way. Really, we provide the tools, and you guys get to use your engineering knowledge to really break down the system how you see fit, as well as being able to look this at on an hourly or a daily rate. So you're assigning the sensors, you have all this data, the data is being pulled in. A lot of times it is just being dropped and not being used, but we're giving you a place to not only view the data, but also be able to use it for those custom analytics. And all of these come together in order to calculate that mass balance to give you that inflow, or to give you that non-revenue water using that billing data. So the next tool that we are going to go into that actually uses the mass balance as well, because it's using that daily loss, or that loss that you already have, is the infrastructure leakage index. And no matter how tight your system is, it is impossible to have absolutely no loss. Unfortunately, we're not operating in a perfect world, so some of those losses are going to happen. So by pulling in information like the length of lines, length of mains, number of connections, things that you can pull directly from your hydraulic model, you can plug that in, looking at the unavoidable daily loss, and then it's pulling the data from the mass balance, figuring out that minimum nightly flow, as well as those pressure sensors being pulled in. You're able to come up with this analytic that shows you what the leakage index for your system is. Where this can be really beneficial is, as we mentioned, no matter what, there is going to be some leakage in your system. But the bigger the DMA, the more leakage you would expect. So how do you compare a smaller system to a larger system? Well, you need to come up with an index that can compare those on a one-to-one basis. And for this, that is what the infrastructure leakage index is going to point to. So you can really start figuring out where you need to dial in your capital improvement plans, where you need to do more exploration to see where you need to spend those dollars. The next tool that is available is creating diurnal patterns. These are the patterns, trying to break down different flow rates, pressures, volumes over certain time ranges, and letting you look at that for different lengths of time, different breaking it down into different segments in order to create that pattern. And once you plug those sensors in and you get these results, this is one of the situations where your hydraulic model and Info 360 Insight can work together, because these diurnal patterns can be pulled directly from Info 360 Insight into InfoWater Pro and use in your simulations. So you can use these patterns directly in there. And then finally, the fourth tool that is in Info 360 Insight, and I think this is one of the tools that a lot of people were asking about when this was going to be available, is the custom analytics tool. We think there is a lot of value in the mass balance, the infrastructure leakage index, and the pattern. But of course, we know that the water industry is the experts. There are going to be analytics that different utilities, different consultants are going to want to have in the software that maybe we didn't even think of. And so adding this custom analytics tab, it allows you to use your sensor data and mathematical functions to pull those analytics that you see fit. The two that we looked at already, and we're going to dive a little deeper in, are the pump performance and the tank turnover. And so in this tool, you can pull different data sources. So think of the data sources as those live links to your data, as well as constant values. In one of these, we are going to look at where Tim pointed out pi was a constant value. And by bringing all of this in and using mathematical functions, as well as tying to those inputs, as you can see, you can look at averages, highest. The if-then statement was one that can make this a extremely powerful tool. But as you can see, even without using any of the special functions, just by using basic math, you have the ability to come in here, run the analytic that we don't have purpose-built in the solution. There's also a validate tool to make sure that your math is right, to make sure that you're not missing parentheses anywhere, just running through, making sure that it can actually calculate. And all of those come together to give you a calculated result. As you can see, this is similar to the dashboard that we looked at, but this is the result that comes out of the pump performance custom analytic, allowing you to look at that power output. And then in a very similar fashion, tank turnover is, I would say, a little bit more of a complex mathematically, but it gives you another view of using those sensor data and math in order to pull an analytic that Innovyze hasn't built directly into the software. And so if we open this, as you can see, just another example of using math to pull out KPIs. In this instance, this is, as Tim mentioned, this is a really good one for water quality, which I think is becoming a focal point more and more in systems that we are working on. And so all of these tools together, the mass balance, infrastructure leakage index, pattern, custom analytics, all those lean back on really getting the return on investment, the ROI for those sensors that you already have in the ground. People have spent a lot of money to meter their system out in the real world. And so a lot of times other platforms give you a place to just view the results. Info 360 Insight, of course, gives you the workspaces which will allow you to do that. But then we also want to take it a step further to where just using that 1 meter, you can use it in multiple analytics, KPIs, multiple data streams, so that it just doesn't become a 1-to-1, it becomes 1-to-4, 1-to-5, really starting to build out the analytics that you're pulling from your system. They can also be set up to use in alerts. And what this is doing is it is reading the live data stream that is coming in and checking to see if it is hitting certain criteria. In this one, we set up an alert if you were to have a pipe burst in one of your within your system. And so setting up these alert criteria so that it is checking against a value for here, a sharp pressure drop and a sharp increase in flow rate, that is a indication that you could have a pipe burst. And you can set up these notifications so that they are coming in real time, daily, hourly, and daily, so that the example that Tim used where someone got a call at 7 o'clock in the morning saying, hey, by the way, we have water running down the street. I think we have a pipe burst. Or the big one in Colorado that just happened a couple months ago that caused a lot of damage and a lot of issues. People aren't alerted to these situations until it becomes a customer problem. Well, by setting up these custom alerts, you can respond to these quicker, more efficiently, and be able to get out there to try and mitigate that water loss. And so all of those, tie back together so that you're really just able to take your data further, able to do more with it. We want Info360 Insight to be a strong dashboarding platform by having you able to view your data, look at your data, being able to interact with your data with these custom mappings, where instead of just, being able or having to create dashboards for each individual sensor, if you just want to get the latest information on the fly, let's say, you can zoom in, choosing a certain sensor and being able to just pull up a chart quickly. But not just doing that, but also really getting more of that analytical piece, making this a place that can help you make more informed decisions, making quicker decisions, just giving it a place to where people can come to this when they first come in the morning, see if there's any issues, get a good overview of their system, being able to run through it and make those decisions even faster. I think that's where Info360 Insight can really take it a step further from just a dashboarding platform. And so that was what I wanted to show today. I'm going to go ahead and stop sharing my screen and switch back over to the PowerPoint presentation.
All right, thank you very much, Hunter. We do have a few questions already submitted from the users, so we're going to get right into those in a second. If you have a question you'd like to submit, please do so now by typing the question in the questions window on the side of your screen and hitting the submit button. All right, let's get started. The first question we have is, where is the billing data coming from, and is it in real time?
Yeah, perfect. So the billing data is a lot of times with the utilities we work with, sometimes coming from AMI. Now, do we kind of suggest taking all, it could be thousands, hundreds, tens of thousands of, a customer individual meters and feeding them all into Info360 Insight? Maybe that's not necessary, right? And it's going to really increase the amount of sensor data you have, maybe unnecessarily individual sensors. But what we've seen, hold on, where'd the question go? What we've seen is folks kind of summarize that data and bring it in a single stream into Info360 Insight. So kind of the lowest increment of time in terms of real time is analyzing data in Info360 at as low as 15-minute intervals, right? Is a lot of times what we're working with when it comes to creating some of those dashboards and graphs and analytics. But again, that's one of the features of the platform, as well as a lot of times, and it's in the next question, where if you've got sensor data out there, and sometimes it's reporting, every 8 minutes, and then it goes out for an hour, and then you've got 15 minutes, and then an hour in between, and 2 hours. And one of the things Info360 Insight can do is sample that data in a number of different ways, right? Do you want to be looking at every 15 minutes, 30 minutes, hour, weekly, daily? Do you want to take the high value from that interval, the average, the close, the starting value, and carry that for that particular interval? So there's a lot of flexibility in how you want to sample that information to make it the most meaningful, right? Because not everything needs to be immediately real time. Like that tank turnover analytic, actually, it's more valuable if you're looking at a daily rate, right? Because a lot of times you're looking at residence time and water age as a function of days, not minutes. So that billing data, yeah, it's kind of as low as, we're looking at 15 minutes, and that's coming from a lot of different data sources. If a utility doesn't have AMI information, which there's still plenty that don't, AMI, AMR, that might be coming from a SQL Server database and being fed into the platform monthly, right? And there's still different things you can do with that in there. So yeah, I think that should answer that question, but feel free to follow up if it doesn't.
All right, Tim, thank you. Now, again, maybe this question is redundant. You did address some of this, but how does the program work in a rural backcountry community where network reception is very little, unstable, and spotty?
Yeah, great question. So in Info360 Insight's case, we are pretty reliant on, again, the hardware or the SCADA historian that a utility might already have set up, right? So the main purpose of Info360 Insight is to take that information and make it more accessible to more folks within and maybe outside the utility, right? One of the use cases we didn't touch on because it just didn't align with the presentation exactly is there's a lot of consultants that help utilities with some of the SCADA information, right? And sometimes it can be difficult for them to request SCADA information and go through the whole get data from the historian and the one person at a utility that has access to the SCADA historian, and that can be a whole process. With Info360 Insight, the idea is you can have as many users as you need to that are able to grab that real-time information for your network and download that for hydraulic modeling, calibration purposes. Again, any of the analytics we talked about, but it makes that data a lot more accessible. So yeah, while the solution doesn't necessarily help with some of those self-service issues, it does make the data more accessible once and give it a place to be gathered, so that more folks have access to what can be, again, sometimes ignored information, but we feel like, especially as kind of folks that have been helping with hydraulic modeling and wet infrastructure for 30 years, be used in a lot more creative ways than sometimes what we're seeing now.
Great. So why don't we, so the next question we have is, my utility doesn't have too many live data streams and sensors. Would something like Info360 Insight still be available to me?
Yeah, I would say, we're working with a number of utilities across the country right now, and certainly, yeah, not everyone's SCADA information is fully complete, but frankly, it's kind of those mass balance areas we described in the beginning seem to be more popular outside the U.S. than they are inside. But what we're seeing utilities do is, you can always start somewhere, right? Start with one area of your network where maybe you're seeing more leakage that you can kind of isolate, and start with kind of that pilot area. And then Info360 Insight can then be your guide, right? Where is the next best strategic place for me to add that new flow meter, for me to add that new pressure sensor, for me to add that new, on-off kind of status across my network, right? In a way that gives me the most bang for my buck, going back to one of those slides earlier, right? So you can start somewhere and see kind of the advantages of where your system is currently with some of the hardware you have in place, live data you have in place, and then kind of use Info360 Insight to be your guide to grow out from there, maybe.
All right, great. And we have one last question. And again, we have plenty of time. If there's any additional questions from the audience, please submit them now. And the last question we have here in the list right now is, what utilities have implemented this type of solution?
Yeah, a lot of different utilities. Right now, we're working with a handful that have been using kind of our on-prem solution, and they're seeing the benefits of having Info360 Insight available in the cloud, so that this data isn't being stored on their own IT servers and configured there, but it's, it's brought to the cloud. It's made more accessible, so that again, more folks within and outside the utility have access to this information. Yeah, so there's more to come on this. I'll be doing a presentation for AWWA Rocky Mountain chapter later this fall, hoping to feature a utility there in that presentation. But there's certainly a number across the country that are seeing the benefits of more efficient, more creatively, I guess, using some of their live time series data and tying it to the hydraulics within their standard water models.
All right. Well, thank you very much, Tim and Hunter, for your time today. Just want to make everyone aware that today's session is being recorded and will be available on the Water and Waste Digest website within the next 24 hours, and you'll be notified when the archive is available. Included in the archive will be the ability to download a PDF version of these slides. I want to thank everyone for attending today. This concludes today's presentation. On behalf of Water and Waste Digest, I'd like to thank Inevise for sponsoring today's webinar, and of course, all of you for joining. I hope you all have a great rest of the day. One other question, as soon as, of course, that usually happens, right? Does Info360 Insight, it's a tough question, feasible for small size applications, few number of users?
Yeah, I see that, and I'd say, give us a call, send us an email. Let's have a conversation about it. Certainly might be. We're happy to kind of take a look at your system, and again, kind of see where your live data streams might be, and be able to tell you, like, based on the SCADA data you have, here's what you could get out of the network, and then we can have that conversation if that's worthwhile for you to go further. So yeah.
All right, great. Thanks, Tim. Thanks for jumping back in there after we were already wrapping it up. Again, thank you everybody for attending, and have a great rest of your day.
Thanks, David. And thanks, everybody.